In this tutorial, we will show you what the new module ibaInCycle auto-adapting can be used for. Therefore, let us have a look at an example. This signal shows a continuously repeating process. In the beginning, the curve will be learned over a certain number of cycles, and from this a reference curve will be built. The following curves will then always be merged with this reference curve. Ideally, the shape of this curve will always be more or less the same. But if there is a bigger change in the shape of the curve, as it is the case here, this could indicate an error in the process. In order to detect an error in the process, the ibaInCycle module can be used. Therefore, we go to ibaPDA and open the I/O manager. Here we already configured an ibaInCycle auto-adapting module named outlier monitoring. Here we have the input signal, which is our process signal. The cycle start trigger tells us when the process starts, in our case this is here, and the cycle end trigger tells us when the process ends. A cycle reset trigger can also be used. In cases where the signal's value is 1, the current curve will not be considered for learning. Skip data signal means that while monitoring, the curve will not be taken into account. Learning allowed is set to always in our case. The integer number condition signal determines the actual operation condition. For each condition, a reference curve is learned. In this case, we only have one operation condition, meaning this value is now always 1. With update reference curve, it will be defined if and how the reference curve will be updated. For example, current or all conditions should be reset or saved. The monitoring section will be explained in the next tutorial. We will now have a look at the profile settings. In the Teach settings, there is the monitoring mode. It defines which specific value of every band of the curve will be learned and hence later will be used for the monitoring. In this case, we chose the average value. The learning time is defined by the number of curves. So in this case, 5 curves are learned in order to calculate a reference curve. You can clearly see this here in the diagram. These 5 curves are learned and all following curves are merged with this reference curve. In the Events view, you can choose between digital or analog event signals. Event mode defines how the curves are monitored. In this case, we selected lower and upper limit for the individual bands. Let's take a look at the calculations. For our calculations, we chose 250 samples. That means our cycle will be divided into 250 points. As we defined 25 bands, every band contains 10 samples. Now to the averaging. Here, the results of numerous cycles will be combined to one averaged curve. In this case, we take the average of one curve, meaning that we get a result after every single curve. Our curve is triggered with a start and stop trigger. Bands are distributed equidistantly over the curve. As mentioned, 25 bands are defined, and as characteristic values for the bands, we chose minimum, maximum and average, which can be chosen from this list. Okay, then let's start the acquisition. We see now our process signal in blue. The digital signal in red shows us when a cycle begins or ends. After every finished cycle, we get a calculation result. This resulting curve in our case was divided into 25 bands. Every curve will also be displayed in the waterfall plot. We see that 3 curves were already learned. We configured our learning phase so that the learning phase is completed after 5 curves. This curve is still within its boundaries. Now here comes an outlier, and as you can see here in the absolute delta value, we detected it successfully. Now the absolute delta value is 0 again, because the following curves are within the boundaries. Here we again see the occurrence of a bigger outlier, and our absolute delta value is even bigger than the one before. We can also look at these curves inside the waterfall plot. When we scroll to the curve with the outlier, we see that both upper and lower limits were exceeded.